Binary search. We are discussing the topic called binary search. So, what is exactly a binary search? So, binary search is nothing but it will, let's say there is a key element. There is a key element in an array. Let's say we have an array 10, 20, 30, 40, 50, and 60. Okay, so we have a key element in the sense we want to find out an element 40 index number. Okay, we have a key element 40 and you have to find out the key element in shortest distance. Okay, so how we will do that? So what we will do is binary search, what it will tell is it will divide the array into two halves. Okay, so what is the key element 40? Okay, so first it will check, first it will find out the mid of this binary. First it will find out the mid value for this one. So how it will find out the mid value? Let's see, 10, 10, 20, 30, 40, 50, 60. Okay, so the mid value will be calculated. The mid value is nothing but starting index and end index. Will give mid value 0, 1, 2, 3, 4, 5. Okay, so 0 plus 5 divides by 2. That is 0 is nothing but starting index and this is end index. So 5 by 2 will be giving the 2. So 2 is the mid value, right? 2 is the mid value. We can't take 2.5. There is no 2.5 index. We can take only the 2. Okay, 2 is the mid value. Now, if key is greater than mid, here key is 40, right? So 40 is greater than 30, right? Yes or no? 40 is greater than 30. So what we have to do is we have to change the mid equals to, we have to change the start equals to, at first this is the starting point. Now we have to change the start equals to mid plus 1. So what is mid value? It is 2, right? 2 plus 1. Now start equals to 3. Start equals to third index. Now again find the mid value. Mid equals to, again find the mid value. Mid equals to, what is the starting index? It is 3. 3. And what is the end index? Again it is same, constant, right? End value will be, end index it is constant. 3 plus 5 divided by 2, 8. 8 divided by 2, 4. So mid is equals to 4. So now mid value, what is the index we are storing at fourth index? Or what is the value we are storing at fourth index? 50. Now if key is greater than mid, key is greater than mid, so key is what? 40, mid is 50. Okay, 40 is greater than 50, no, false. Now what you have to do is you have to say end equals to, sorry, start equals to, okay, start equals to mid minus 1 you have to take. Mid minus 1 you have to take. Now what is the start? What is the mid? Mid is, what is the mid? 4. 4 minus 1, that is 3. Start is 3. And sorry, it is end, I think. Yeah, it is end. Sorry, not start, it is end. End equals to mid minus 1. So what is mid? It is 4 minus 1, that equals to 3. Now end equals to what? 3. And here our start equals to also 3 itself. You can check here. Our start equals to also 3. Okay. So if I find mid again, mid equals to start is 3, end is 3, divided by 2. 6 by 3, 3 is the mid again. Now we will be checking if key is greater than or equals to mid, we'll say that here 40 is greater than or equals to 40, right? Mid is 3. So here index 3 will be storing the value called 40. Now it is true, right? The condition is satisfying, right? The condition is satisfying. It will return the index as a 3. Okay. A third index only, the value 40 is stored. This is the background of binary search. Okay. So what binary search will be doing is it will it will divide an array into two halves by finding the mid value. Okay. If the mid value is greater than if key is greater than the mid value, we will be calculating the start. Start equals to, we'll be saying, we'll be using the formula called start equals to mid plus 1. So a mid value. So mid value, let's say in over here, the mid value came as 2. 2 plus 1, 3. The start becomes 3. So from third index, you have to start it. And end index, it remains same. It didn't change. Okay. Again, what we did is we again find the mid value. 3 plus 5, 8. Divide by 2. So that is 4, we got it mid. So now mid value is 4 again. So 4 is nothing but 50. Again, we compared 40 is greater than 50. No, it is false. So what we did is we like 40 is greater than 50 in the sense. So the value 40, it is not right side of this one. So it is left side of this one, left side of the 50 itself, right? So what I did is I have changed the end equals to mid minus 1. So what is the mid value? Mid value is my mid value is 4 and end becomes 3. Now start and end points the same. If start and end values are same, then you can think like that you found the key. Okay, this is a binary search. Okay, so let's you
So
understood, right?
for this, that total array, like total value has to be sorted, right?
Yeah, it should be sorted. If you want to perform any binary operations, first, like if you want to perform any binary search, you should perform the binary search on sorted array itself. See, let's see if you see a book full of pages actually, starting from first page to 100 page. All the pages are sorted in order, right? If you have a sorted array, then only you can apply binary search. If there is no sorted array, you have to sort the array first, then you have to perform operation like binary search on it. You have to apply binary search concept on it. Okay, so to apply binary search concept, you should have a sorted array. Okay, so here in arrays we have, like, we don't need to write in arrays, we have a ready-made method. Actually, I just explained you what exactly binary search is. Okay, so in arrays we have a ready-made method. Okay, so we have a binary search method which will be taking the array and the key element you want to search. Okay, so to find the key element, we did a lot of things actually. Key element, index number, we did a lot of things actually. Okay, so let me record this session. Okay, it's in recording format only, right? Fine. So we have a binary search. So the binary search method will be taking the array and it also take the key element which you want to find out, index for the key element. So in this array, you have some element and you want to find out the index for that key element. Okay, so this will return integer and it is a static method, public static int binary search. So, okay, let's see a simple example. Let's say you have a sorted array. Let's say int arr equals to 1, 2, 3, 4, 5, 6, 7, 7, and 10. and 10. All are in sorted order only, right? Okay, fine. Now what I'll do is I want to find out the key element, let's say 6. So I'll say arrays dot binary search of binary or binary search of an array, and I want to find out the key element. What is my key element? 6. I want to find out the key element index. So this will return the index of that key element. Okay. So let's see a simple example. Let's see a programmatic example. I'll use the same. I'll take the same array and I'll try to find out the index of that key element. Finding key element of given index. Okay, public static void main, finish. Control D. So here we have an array. Now what I'll do is I have to find out the key element index number. My key element is 6. So let's say arrays dot, what is the method? Binary search. So here you are passing the array and you want to pass the key element 6. So assignment index of given key. Right, sys out index of given key element, given key. Here I'll give the key element name. I'll do one thing. I'll store the key element in a variable 6. I'll give this key element over here so that I can use it in my sysout. So I'll give it over here. So key element index of given key element is, I'll give the index. Fine. So we have taken an array and we have given the key element, and I want to find out the key element for the I want to find out the index for the key element 6. So let's run this one, Java application. So the key element is 5. The index where the key element is stored 6 is 5. In 5th index, the key element 6 is stored. Okay, that's it, right? Okay, so this is the binary search method. So let's see one more method.